Okay, so the first stuff we learned or at the start of your unit anyway, was the graphene. Okay, so here's two different functions to graph. So I'm going to start with 2 to the x. Okay, so we're going to go 2 to the -1, 2 to the 0, and 2 to the 1. Okay, I'm just going to put a few values in for x. Okay, what is 2 to the -1? Do you remember how to do that negative exponent? 1/2. Doesn't matter, anything to the 0, 1, 2 to the 1 is itself. Okay, so here's those 3 points. There's those 3 points. And what do I know about an asymptote here? There should be an asymptote. Okay, y = 0 is the asymptote. And our equation. So this will increase as we go up. As we go left, it flattens at 0. Okay, you know what, I'm going to change this. Let's do something like this instead. That one's too easy. I'm going to have some transformations on your test, so I may as well practice a few with some transformations in it. Okay, so the base is 1/3, so I'm going to do the same kind of startup. I usually take a -1, a 0, and a 1. Okay, what is 1/3 to the -1? What happens there? It becomes 3 because it flips. Anything to the 0 is 1. Anything to the 1 is itself. Okay, so that gives me 3 coordinates on my graph. Okay, so what did I throw in here? What is this? A, B, C, or D? It's a A. And this is a D. If you're wondering what does a B look like, if that was the A B would look like if I did this. This would be a B. Does that make sense? Because it's with the X. Okay, so my equation is going to be this. Nothing with the X, -y plus 2. That's what happens with my transformations, -y plus 2. So therefore, I'm going to run my 3 coordinates through. Okay, so I wrote down all my x's because nothing happened to them. Okay, so negate -3 plus 2, -1 plus 2, -1/3 plus 2, Okay, what do I already know about the asymptote here? This one was y equals 0. What's this one going to be? Y equals 2, because it's shifted up 2. Okay, and then I guess we can't forget, if we're making our own graph, to put some numbers on things. Okay, so you'll have some kind of exponential to graph on your test. Okay, so this is a log graph. So I'm going to grab the base again. So the base is 5. And I'm going to do the same process here. 5 to the, and I pick -1, 0, and 1. So 1/5, 1, and 5. Okay, but this time, what's different about my coordinate? My coordinate is output, comma, input, right? It just gets switched around in that order. Okay, what's going on with that? An A, B, or a C, D, which one? A C. So I'm going to be moving left 3. That's what I'm doing to my coordinate. Okay, what do I know about asymptotic behavior on a log graph? Normally it's x equals 0, right? So exponential, we had a horizontal, this is a vertical, but I moved left 3. So I'm going to put that. Hard to see on my thing here. So there's my asymptote. And then let's see how our 3 points fit into this. Okay, and then it asks, what's the domain of this? So how far left do we go? We go to a -3, to infinity. And what kind of bracket would I want on that number? What do you think? Square, round? Should be a round, right? Because we're not ever going to touch that asymptote. We get really close to it. Okay, log stuff. So rewrite in exponential form. So that's the base, that's the result, and that's the exponent. right? So those are the components of a log equation. So if I want to rewrite it in an exponent form, the base to the exponent equals the result. Okay, versus this one, rewrite it as a log, so log, so down here I need the baby base, so 2, the result equals the exponent. Okay. Solve this log equation. Okay, so I'm going to rewrite it in exponential form. So can you think about that? The base is here, this is the result, this is the exponent. So can you maneuver that into exponential form? So 3 to the 3 equals 4x plus 7. Okay, most of this stuff you don't need a calculator for, so what's 3 times 3 times 3? 9 times 3, which is 27. Okay, subtract 7, divide by 4. Okay, we need to always check with logs though. When we have an answer here, a solution, we need to understand that this result always has to be positive. So is 5 an answer that we can keep? Yeah, because if I plug it in, 4 times 5 plus 7, that's positive, so it's good. Okay. Solve this exponential equation. Does anybody remember the strategy when you see this type? Base of 5, base of 1/25. What's the strategy there? We want everything to have the same base. Because these two base values, I can rewrite them both with something. So what number is common as a base number for those two? I think we could use a 5, right? So 5 to the 1 or whatever, you don't need to really write that. And how do you rewrite this with a 5 base? 5 to the -2, okay, because negative moves it to the bottom. So now, if the bottoms are both 5, the base is both 5, I can conclude, hey, the exponents just need to each equal. So the exponent x plus 9 has to equal the exponent. What do you do with that? What kind of math operation? Multiply, and don't forget to distribute it. Okay, so I'm going to move some stuff here. Okay, estimate, we're going to use benchmarks to estimate. So this is the base, this is the result. So I want to figure out the exponent. That's what I'm doing. Okay, so what do I know? I know 3 squared is 9. Okay, so that's not really close to 40. I know 3 cubed is 27. we're not at 40 yet. I know 3 to the 4th is 81. So I for sure know the value of this is between 3 and 4. It's approximately 3 point, what would be reasonable? 2781, 40 fits closer to 27, right? I don't know, maybe a 3.2. Okay, this is an estimate. Okay, so I would deduct you if you guessed a 3.6 because it's not more than halfway, right? Because your 40 is closer to the 27 than the 81. Okay, you would also lose a mark here if you went x equals, you would lose a point because there is no x in there. It's just what's the value. That'd be like me saying, hey, what's 4 times 5? And then you saying x equals 20. Okay, so don't throw in an x if I don't have an x. Okay, evaluate. So I'm first going to work with this. So what's the exponent that makes that happen? So this is what your brain is doing. What exponent makes that happen? So 2 to the, so that would be a 3. Okay, because that exponent would need to be 3. Okay, now again, your brain is thinking, what's the exponent that makes that happen? So the base of 3, some kind of exponent, results in a 3. So this exponent would need to be a 1. And again, I'm not throwing x equals 1 into this because I don't have x's or anything. I'm just asking for the value. Okay? Okay. I need you to think about, on this one, how am I going to come up with 45, and I'm only allowed to use a 5 and a 9, and I'm allowed to use multiplication, division, and exponent stuff. So how will you get yourself a 45? Did you think to do a 5 times 9? That's how you do a 45? Okay, now log rules. If there's a connection in here with multiplication, I can split them into separate logs with adding. Okay, and now I'm just going to replace because I know those from the given statement. Okay, next. Okay, so there's a 25 here and a 3 here, but I can't use those numbers. I can only use 5s and 9s. So what could we maybe replace 25 with? 5 squared, and did we think about doing a square root of 9 to replace the 3 with? Okay, now do we all know that the square root of 9 is the same as a half exponent, right? Okay, so the rules. Exponents can become coefficients. So 2 log A5. And when something's connected with division, it can separate with subtraction. And then I have another exponent going to the front. Okay, so mathematically, you're going to do 2 times 0.898, subtract a half of 1.2262. Okay, I just want to tell you, I for sure put something like this on your test. If I ever did something like this, can you think of how to get this number? You got to try something. So play around. Can you think of a way to get 16.2? How are you going to get 16.2 using something with those numbers? Yeah. 9 divided by 5, you said, and then times a 9? Okay, so in other words, that's like a 9 squared over 5. Yeah. Okay, so I just want to warn you on your test, I might have some kind of weird number, but you have to play around until you get something, okay? Only using multiplication, division, exponents. Okay. I'm not doing that question C, by the way. Okay, the next one here, when I separate this, how many different separate units will I have? I'm going to have that, that, and that. I'm going to have 3 separate units. Okay, so log A5, multiplying becomes add. 3 log AM, division becomes subtract, exponent goes to the front. Okay, next one, now I have to put it back together. So log B of a bunch of stuff. So basically, if you see something's positive, it's on the top. If you see something subtracted, it's on the bottom. So the 4 is on the top. M is on the top, and it has an exponent of a half, which is also the same as me writing a root. And the N is going to be on the bottom. On the test, I feel like this might be a little bit tricky. So let's just talk about this one. Okay, here's why I trick people. how many units would you have when you separate them? How many different terms get separated? 3. This, and do you understand that that doesn't get separated? Okay, so that is one of the places I see quite a bit of errors that get made. Okay, it's still connected as x plus 2 and can't separate. Okay, so don't make that mistake. Okay, solving this log equation. So the first thing I'm going to do is I'm going to put the separated logs back together, because they're both a log 6, so I can put them back together. So they separated with adding, so they're going to be multiplied together. Okay, now what? Should we turn the log form into exponent form? Does that make sense? So the base is 6 to the 2 equals a result okay, and then I just distributed that multiplier. Okay, what do you want to do in an equation when you have x squareds and x is involved? Does it make sense to make one side 0? So I'm going to go 0 equals so I'm going to move 6 squared and also turn it into a 36. I'm thinking this factors, right, with a 9 and a 4. Okay, we're not done. Remember that these positions always have to stay positive. These positions in a log, the result always has to stay positive. So is 9 good? If I plug a 9 in, if I plug a 9 in, did all those stay positive? Yep. If I plug in a negative 4, that's not going to work. Okay, the next one, you know what, there's actually 2 ways to do this, so I'm going to show you both ways. The first method, I'm going to move everything to one side here. So this is method 1, move everything to one side. Okay, now I'm going to put everything together. Okay, so that was some separated log rules. I'm going to put them together. So anything positive is on the top. Anything with a subtract is on the bottom. Okay, so now I'm going to go log, turn it into exponential. So the base is 3 to the exponent 0 equals the result Okay, what is 3 to the 0? So that's just a 1. Okay, now I'm going to cross multiply this. So 16x minus 32 equals x. So negative 32 equals negative 15x. Okay, and it, just checking, does it make everything positive? Yeah, it's good to go. Okay, so here's the other method. So on the left side, I'm going to combine. So on the left side only, I combined them. Okay, now do you see that these both have log 3, log 3? They both are that way. So can we conclude this has to equal this? Does that make sense? Because they both had a log 3 of something, the log 3 of something. So x over x minus 2 equals 16. Okay? Just because they both have the same front, log 3 of something, log 3 of something. Okay, I'm going to stop there because it's all the same from there on out, right? Okay. How do we solve something that looks like this one? I definitely cannot put the same base in this one, right? Can't write that way. So the only other way to get an exponent solved for is to log both sides. So I'm going to log both sides. Okay, so we have to do all those rules. So log 5, the multiplier splits, add exponent in the front. Okay, so those were my rules. I split with add, and I moved any exponent to the front. And it was really important to keep that exponent in brackets. And on the right side, it's an exponent moved to the front. Okay, so that's like 1 point already if you apply the log rules. Okay, so the next step would be that I'd have to distribute that. Okay, when you get to this stage, you say everything that contains an x will be on one side of the equation. Everything that doesn't contain an x will be on the other side. Okay, so I moved, all I did was move that. Okay, once you have all of the x stuff on one side, you can GCF an x out. Okay, so it's all about, can you type it in from this point on? Typing in properly to get x alone here. And you'll have to answer to 3 decimals, right? Anybody matches me? That'd be nice to know. Okay, number 2 on this. Okay, my exponent has the variable. I cannot do anything with common base stuff, so I'm going to log both sides. But here's a hint. If I see an e, instead of logging both sides, I'm actually going to natural log both sides. Okay? You don't have to, but it will make your life a little easier. Okay, so move exponent. Move the exponent. Okay, so here's why I chose that, because the ln of e is, hey, what's the number? If the base was e and the result was e, then this is a value of 1. Okay, so I'm going to distribute this. Whoops, I'm not ready for that yet. Redo. Okay, so we have to move some stuff around here. Let's go moving that, maybe. Okay, so move x stuff together. GCF your x out. Anybody else getting a 12 point? Okay. Okay, some word problems. I'm going to tell you right now, I put 3 on your test. I put a population one on your test. I put a pH one on your test. And I put a money one on your test. Okay, so it gave us the formula. Determine the rate of growth for this. A city grows from 20,000 to 26,000 in 8 years. Okay, so A is my population after a time. So that's going to be the 26,000. P is the starting population. So that's 20,000. E to the rate, which I don't know, times 8 years. Okay, I'm going to start by dividing the 20,000 out. Okay, since that actually comes to a nice decimal, I can do that. Otherwise, you should just leave it in some kind of fraction. But it came to a terminating decimal, so that was good. Okay, my variable is in my exponent, which means I'm going to have to log both sides. But I do see an e here, so it might be easier if I ln both sides. So move the exponent to the front. Oh, why did I put 18 is a good question. It's just 8. Okay, ln of e has a value of 1. So to get r, I need to divide by 8. So that's the piece you need to type into your calculator then. So this will probably be a decimal because it's a rate of growth. So 3 decimals for your rate. But you probably don't want to get rid of it, right? It's still on my calculator. What will the population be in 20 years? So A equals, we started with 20,000, e to the 0.03 ... times 20. Okay, so I'm giving you the ... dots, meaning it's on my calculator. Okay, so we're going to do this first. That times 20 in my calculator equals. Okay, now I'm going to do this. E to that answer, so e to that exponent equals, so I'm at like 1.92, and then times 20,000. And here is a spot where you can go to a whole number because it's a population of people. Okay, so here's the formula for making payments. You're getting compounds of interest, and you're going to end up with money at the end. Okay, so if you deposit $100 per month, that would be your P, because that's your payments, your periodic payment. 3% annual, so 0.03, compounded monthly, so divided by 12. How many pay periods? So we're going to be looking for n. How many pay periods? We're looking for n before it reaches a future value of 10,000. Okay, so there I read it. I picked out all my variables. So I want 10,000. I'm going to keep putting in $100. Okay, so don't forget, compounded monthly means you're going to have to do a divide by 12 on the rate. Okay, so I'm okay if you do a bunch of algebra at one time. So I'm going to work to get that alone. So I'm going to do all these things. I'm going to go this number, I'm going to be dividing by 100 and timesing by the fraction and then adding 1. So if you're okay to do all of those at this kind of one time, to get rid of that, and rid of that, but obviously the plus one has to be the last thing. Okay, I got a 1.25 when I did all those maneuvers. That was good. Okay, so my variable is in my exponent position, so the trick is to log both sides, and I don't see any e's, so there's no point in that. I'm going to log. So this is a unit, it doesn't separate. The 1 plus something, that doesn't separate. So I'm getting 89 and change. Okay, so at this point you have to be really careful on what the question's asking you. I noticed that one in your book tried to trick you. If I said, how many full payments would you need? You're going to do 89 full payments, and then you're also going to make a 90th payment, but it's going to be a partial payment, right? Okay, so that's how that's working. So this question just says, how many pay periods? So we're going to need 90. You always have this many full payments, and then you have another payment that would be a partial payment. So that would make 90 payments.